Yeah, we were dealing with function of a function rule or chain rule. We have dealt with one example. Now I want to use the trigonometry form of example here to deal with our function of a function rule. The first explanation, if you don't understand that first explanation, then I'm going to give another concept of dealing with function of a function rule. I've told you function of a function rule encompasses two different functions. Sometimes it can be three functions. That means you are going to be differentiating 3 times. If it equals 2 functions, you differentiate 2 times. When you look at this, it equals 2 functions because you can differentiate cos on its own and you can differentiate inside on its own. So we have 2 functions here. Then that requires chain rule. Now, if I don't want to use the first explanation I gave the other time, then I can just say the function inside. Anytime you have this, we have the inner function. This is the inner function. Then everything here is called the outer function. Anytime you want to deal with chain rule, you can just say the inner function will be represented with another variable. Let me say 2s plus 1. Let's approach it this way again. If you don't understand that first approach, then you can write your y as cos u. I've written it as another variable separately, cos u. Then that means in this case I can say my y depends on u. So I can find the y du. The y du is going to be what? Minus sine u. Also, from this equation, which we can call equation 1, from this equation 1, we can say u is equals to 2s plus 1. Then in this case, I can find my u, which depends on x, and that is what? 2. Now, we are able to get the y, the u, and we are also able to get the u, the x. Then don't forget that we said that we are looking for the y ds. The y ds is a combination of the y, the u, and the u, the x. When you look at this, the u, the x cancel themselves, and we are also having the y, the x here. So that means the y, the u, which I've gotten here to be minus sine x, minus sine u, sorry, multiplying it with what? The u, the x, and that is 2. Then my answer here is minus 2 sine u. Then we have minus 2 times sine u. Then we replace our u with what we were given, and my u is what? 2x plus 1, and that is the derivative of this. Now, moving on to the differentiation of exponential functions. The differentiation of exponential functions. Now, we are just going to talk about exponential function. Exponential function, don't let us delve into the explanation of that, but let us deal with how do we differentiate, for instance, exponential s, y equals to exponential s. Now, if you look at this exponential function, the power s does not have any coefficient, which can be minus 2 or plus 2. So it's just, the coefficient here is just 1. So differentiating this, an exponential function is a continuous function, which will give you back that exponential function. That's just a simple explanation. When we delve more into it, you will understand it better. You also have y to be exponential minus 2s. You can see that this one is different from this. The power we have here, this one has 2 functions. This one we can also apply the chain rule. We have exponential, which is a function on its own. Then we have this one that is on top. What I mean is that we can say we can differentiate this whole function, exponential minus 2x, with respect to s. Then you can also differentiate the function above, which is 2s, with respect to s. So this is what we have here. Differentiating this whole function give us back the whole function according to what we said here. Then differentiating this is going to give us what? Minus 2 when you differentiate that. Then our final answer is minus 2 exponential minus 2x. Hope you get that. I've differentiated it twice. That's function of a function rule or chain rule. Moving on to other examples. Then we can also have y to be exponential 3s plus 4. I said this one is made up of 2 functions also. This one is the inner and this one is the outer. Then the inner, I can say u is equals to 3s plus 4. Then we can write y to be, you know that u here is a function of x. U depends on x here. Then y can be rewritten as exponential u. Then we can say y is also a function. It's also a function of u here. So we can just find u prime here. My u prime here with respect to s is 3. My y prime here is also going to give me exponential u. So what do I have? Then we continue by saying the y, the x is going to give us the u. It's going to give us the y, the x, which is this, the y, the u, which is this. You have y depending on u, multiplied by the u, the x. Then substituting what we have there, the y, the u is exponential u. The u, the x is 3. Then we have 3 exponential u. Then we have 3 exponential u. My u will just be what? 3s plus 4. And you are done with that. Then you can deal with this on your own. Now moving on to product rule now. We are dealing with product rule. When do we apply a product rule? We are going to apply product rule when you are given two functions, like y is function is equal to what? U and v. And your u or y can be written as, y can also be written as u of s and v of x. It means that there is a function of x here, which is my u. There's also a function of s here, which is my v. When we start applying it, you will understand this concept. It means that two things are multiplying themselves together and they are both depending on s. They are both function of x. So how do we derive this product rule? I will derive the product rule for you now. Using the first principle, we normally derive using the first principle. We know that y was given to be what? F of x from our first principle. And y plus increment in y is equals to, each of these will be increased. That is u plus increment in u. And v plus increment in v. That's what happens. Then we have y plus increment in y. Then you expand this out. U, v. U times v, u, v. U times changing u, changing v. Then changing u and v plus v, changing u, plus changing u, changing v. Then what do we have? We take our y to the other side. U, v, plus u changing v, plus v changing u, plus changing u, changing v. My y coming here, just have minus my y. And my y was given to be what? Minus u, v. Then what happened? We take the slope, changing u by changing x. Then we can write it as the lim of this, which one will be the y, the x, equals to the lim, changing s approaches 0, changing s approaches 0, changing s approaches 0. Then we have uv. You observe that your uv cancel your uv. Then we have u changing v all over changing s plus v changing u all over changing s plus changing u changing v all over changing x. What happens here? My v is a function of x here. Then the limit here is going to be u, the v, the s, because the u depends on x. Plus my v, v depends on s here. U also depends on s. Then we have v, the u, the s. Both of them, combination of both of them does not depend on s. Then this is 0. Then we have the y. The x is equal to this. And this is called the product rule. We can have some questions to explain this better. We can be given that y is equals to s to the power 5 exponential 2x. Y is equals to s is power exponential 2x. Also, y is equals to s is to the power 3 sine 2x. So dealing with this one after the other, let's first deal with this. You observe that s is power 5 exponential 2x. This one is a function of s, which is the u. This one is also a function of s, which is the v. Then we can say my u is equals to s is to the power 5. My v is exponential 2s. According to the formula, dy dx is u dv dx plus v du dx. So all you just need to do is just find your du dx, and this one 5s raised to the power 4. Then what? My dv dx, this one is 2 exponential 2s. Substituting that, then we have our dy dx according to my product rule, exponential 4 5s exponential 4 plus, that's u. I've not applied my u. My u is what? S is to the power 5. Then my dv dx is 2x 2 exponential 2x plus my v is exponential 2s. Then what? My du dx is 5s raised to the power 4. Then we have 2s raised to the power 5 exponential 2x plus 5s raised to the power 4 exponential 2x. Then we can factorize here by saying 2s raised to the power 5 plus 5s raised to the power 4 exponential 2s. And that is your answer. You can deal with this on your own. Are we good? Now we have explained what we call the product rule. Then we are moving to the next aspect of it, which we call the quotient rule. Quotient talks about division of function, and that can be represented with y equals to u over v, where you will have u to be a function of x and my v is also a function of x. Although we can derive this quotient rule, but it's a very long procedure. But let's just give us our quotient rule, which we are familiar with. Our dy dx, when you go through the derivation, is going to be v du dx minus u dv dx all over what? All over v squared. This is what we know as quotient rule. V comes first, du ds minus u dv ds all over my v squared. So let's apply that in some of the questions we have here. We have y equals to tan x. So let's deal with this first one. Y equals to tan x, which can be expressed. We have given us the derivative of this, which is sec square x when we differentiate it. But let's get that. We can also say y is, this is tan s. We can say it is sine x all over what? Cos x. Then let's differentiate this. You know that this is your u. The one at the top is always your u. The one below is always your v. And this is a function of x. This is also a function of x. So that coincides with the quotient rule. You only apply quotient if the denominator is a function of s. If the denominator and the numerator are a function of s, then apply quotient rule. So what does the quotient rule say? It says that your v du ds, your v du dx minus your u dv ds all over v squared. So I'm just expected to get my u. My u is sine x. I'm expected to get the u dx, and that is what? Cos x. My v is cos x, and I expect to get the v dx, which is minus sine x. Then I can also get my v squared, which is cos square x. Then applying this or substituting this to it, we have my dy ds, which is my v du dx. My v is what? My v is cos s. The v dx is going to be my v du dx. My du dx is also what? Cos s minus my u, and my u is sine x. Du dx is what? The v dx is minus sine x dv dx. And all over v squared, my v squared is cos squared x. Cos, this will be cos square x. Minus times minus is going to be plus sine square x all over cos squared x. We have in our trigonometric ratio that cos square s plus sine square s is going to be 1. So applying that here, we have this to be 1 over what? Cos square x. Cos, its inverse. This is the inverse of cos. Inverse of cos is secant, and that is what? Sec square s, which we have said when you differentiate tan s, you have sec square x. Now we said why the second example on quotient rule is sine s all over s squared. My u is the one in the numerator, sine s. My v is the one below, s squared. Then in our quotient rule, which is the y, the s, is my v, the u, the s, minus my u, the v, the x, all over what? All over v squared. And from here, we can have our du dx from above here. Du ds is cos x. My v, the v ds is 2x. Substituting that in our formula, we have our dy dx is going to be my v. My v is s squared du dx, and that's cos s, minus my u. My u is sine x the v dx, which is 2x, all over v squared, and my v squared is going to be s squared raised to the power what? To the power 2. And we have s squared cos x minus 2s sine x all over s raised to the power 4. Yeah, we are here, s squared cos s minus 2s sine s. What can we do else? So let's just try to factorize the numerator. Then s is common to them. S cos x minus 2 sine x, s is to the power 4. This one can go, and we have s cos s minus 2 sine s all over s is to the power 3. And that will be the final answer on this. Yeah, moving on, we are moving to the differentiation of implicit function. The English they are using here is called implicit, and linguistically speaking, what does implicit mean? Implicit is talking about something that is not clear. When we started our differentiation, we started from the concept of y is a function of x, and this is explicitly what this is an explicit equation. It means that I can say if y is a function of x, then you know that the y is the dependent variable, and this one is the what? Independent variable. Independent variable. We know one that is depending on the other. So this one is explicit, this one is clear. And this is an example of an explicit function, those one we have been dealing with since morning. Y is equals to 2s squared plus 3s plus 5. This one, y is on the right, is on the left hand side, and we have the function of x on the right hand side. That's an explicit function. But looking at this question, when we are given something like this, s squared plus y squared equals to 25. We have to find the y, the s. Actually, the y is supposed to be the dependent variable, and the s is supposed to be independent variable. But this type of equation, you will see that y and s, they are found together. We can't differentiate the one that is dependent on the other. So all you just need to know is that this is an implicit function, an unclear function. Then you just differentiate directly by saying d s squared dx plus d y squared dx equals to d 5s ds. Each will be differentiated with respect to x, each of the functions. That's what you do for an implicit function. So if I'm differentiating this one represents two functions. It's like function of a function with yes, because we have the power here and we have x here. So you differentiate with respect to power first by taking the power down using the power rule. D x squared, that's 2x. Then we have the x dx. You differentiated twice. The power differentiation of the whole function, that's 2x. Then x is a function with respect to x. The same thing will be applicable to this. Differentiating with respect to power, which is 2y. Y also depends on x, that is dy dx. Differentiating constant is 0. Merely looking at this is the s ds. We have 2x plus 2y dy dx equals 0. We are expected to find dy ds, so make it the subject of formula. 2y dy ds is now equals to minus 2x. Now 2y minus 2s, you have to make dy ds the subject. That's what we have to make the subject of formula. So that's what we have to find. Divide by 2y. And we have dy dx is equals to minus x all over y. Then you have gotten your dy ds. In continuation, we are going to deal with another example of an implicit function, an unclear function. So what do we have? We have the question given to us up there. X squared plus y squared minus 2s minus 6y plus 5 equals 0. Differentiating each of the function, I'm going to write it again the way I've just written that. This is x squared ds plus the y squared dy minus d 2x ds minus d 6y ds plus d5 ds equals to d0 ds. Then what do we have here? Applying the same concept, product rule here. We have 2x dx dx. We are differentiating twice plus 2y dy. Sorry, this is supposed to be dx. Dy dx minus 2. When you differentiate this, that will be 2 dx minus 6. Differentiating this constant dy dx plus differentiating this constant here 0. Differentiating constant 0. Then we have this cancel themselves here. This cancel themselves here. And this 2x plus 2y minus 2 minus 6 dy dx equals 0. This is dy dx minus 2. We have 2s plus 2y dy dx minus 2 minus 6 dy dx equals 0. We are expected to make dy dx the subject. So collect like terms now. 2y dy dx minus 6 dy dx. The constant or any other thing should be taken to the other side. This is 2 minus 2x. Dy dx can be factorized out. So we have 2y minus 6 dy dx is now equals to 2 minus 2x. Making it the subject, dy dx is equal to 2 minus 2x all over 2y minus 6. And that will be your answer, which you can also factorize to be, can factorize this to be 2 into bracket 1 minus x into bracket 2 is also common, y minus 3. And we have this cancelled out. And we have 1 minus s into bracket y minus 3. So your dy dx is finally this.